What's going on, you guys? Welcome back to the channel. In today's video, I'm going to show you how to make the classic game Snake in Python using PyGame. Alright, I'm super excited to bring you guys this classic game tutorial. Snake is one of the first games. It's super fun. It's super addictive. Basically, as you eat more food, your body gets longer. And it's a really great coding exercise and introduction to a lot of Python and object-oriented concepts. So, if you do want the code and you don't want to follow along line for line, there is a GitHub repository. The link is in the description of the video. If you do grab the code and you're just here to peace out, then be sure to leave a like on the video, subscribe to the channel. It helps me out a ton, and I'm happy to bring all this content to you constantly. Alright, so super excited to bring you this classic game tutorial. Gonna do it all inside of Python using PyGame. So if you've done any projects with PyGame, you know you need to start by importing PyGame. If you haven't installed it already, you may need to run pip to install it. And then two other modules we're going to use in this are the system module, so import sys, and then also the random module, so import random. And then whenever you are doing a PyGame game, it's a good idea after you import PyGame to just do pygame.init right at the beginning to initialize it. And I think let's just take a look at how we want to set up this overall game logic. So there's really only two things going on in Snake. There's the snake's body moving throughout the grid, and then there's the food that you're trying to track down. So I think what we should do is we should just make two object classes. One will be the snake itself, your character, and then let's go ahead and just come down here and let's make the second one for food. And you'll see why I'm doing it this way, I think, once we get into filling these out. But basically, initially, I'm just going to put pass in both of these, and before we run anything, we're going to come back. But I want you to think of all the objects that need to go into the game right off the bat. So basically, we're going to have the snake, we're going to have the food, we're going to need a space to actually draw the grid, so we'll call that define draw grid, just like that. And then beyond that, so I'll do another pass right here. Beyond that, we really just need a spot to store game variables, so I'll call that a game variables library, and this is where we'll put things like the screen width and the screen height. So for this game, because it's just a nice little game, it fits nicely in a 480 by 480 square. But we'll put all of our game variables here as we define them, and then really the last thing we have to do is just define our main game loop. So this main game loop is something that I spend a lot of time setting up in kind of every game, and we'll try to go quickly now because we do it every single game, so hopefully you've seen a few other tutorials, but I'll try to explain it as we go through it. So you want to create a clock because that's going to control the speed at which your game runs. So you just do pygame.time.clock, and then you also want to define a screen by doing pygame.display.setMode. And then you give it a few arguments. So you give it as a tuple your screen width and height, and then 032, there we go. And you define your screen. And then if you're gonna have a game where you want the potential for like a menu, a few levels, anything like that, it's not a bad idea to also define a surface. And this is something that if you've made some simple games before, you maybe have skipped this step and just drawn everything onto the screen. But technically, this is the best way to set your game up to have multiple screens throughout it, multiple surfaces that you can draw things onto. So to create one like we want for Snake, which is just going to take up the entire size of the screen that we just defined, just use pygame.surface with a capital S and then screen.getSize. And then below that, just add this surface equals and then surface.convert. Okay, and now let's move on. So below that, we're going to want to call the draw grid function, all inside the main loop here. So to do that, you just call the function that you made for that. Sorry, it's a little late in the evening over here. And then since we're going to draw the grid onto the surface and not the screen, I'm going to pass surface in here. And then up in our draw grid function, you're going to want to tell it right away that it's receiving a surface to be drawn onto. So we'll fill in the draw grid surface. We'll fill in the draw grid function next, but let's just finish defining the basics of our game loop here. So we'll draw the surface, and then the next thing we want to do is create an instance of both of our classes. So we're going to have the snake, and we're going to have food. And you can tell the instance of the class separate from the class itself by upper and lowercase. So the classes defined with a first letter caps is kind of the standard Pythonic way of writing it. And then your instance with lowercase is how you would tell that that's a specific instance. Okay? So we define those, and then we'll just say the score is equal to 0 when the game boots up. And now we put this while true. And this is now the while loop that we're setting up, where as long as the game has not been exited, then we can keep playing, and we can put all of our things that need to happen every loop of the game underneath this layer. So we'll say clock.tick, and here's where, if you have like an action game like a platformer, you might put an FPS here, like 60 for your frame rate. But since this game is Snake, I'm actually going to use this clock to control how fast the snake moves throughout it. So we're going to do clock.tick at 10. And then in here, we'll be putting a lot of snake and food sub functions. So like .draw, .update, receive player input. So we'll put those things like here once we've fleshed them out underneath the class. And then we'll, again, draw the grid on the surface. And it's important actually to put these in both places, because the first place that we did this exact line of code is just doing it initially before the game boots up. Oop. There we go. So if you didn't have it here, every time you boot up the game until kind of 1 or 2 seconds in, 1 or 2 frames, you might not even be able to detect it, but technically the game would start up without a grid until it got to this point. Doing it here in the beginning is a really good way to make sure your screen loads in right away. Okay, so then let's just go ahead and handle what we need to do to like update the screen and then close it. So the last thing that you need to do is just pygame.display.update. And then down here, obviously, you need to actually call that main. So the main function that we made for the game, you need to call it. And let's go ahead now and actually fill in the drawing the grid function. So go up to draw grid, and we're going to use this a few for loops to make it procedurally generated. It is going to be so much faster than if you were going to try to go in and draw every rectangle where it needed to be. So what we'll do is we'll say for I in range 0, and then what I think we should do is we should make some new functions that are going to tell us how large we want the grid to be, not functions, variables, because we want this to be from 0 to however many grid rows there are, and then for the X we want to be from 0 to however many grid columns there are. So we need a few new variables here, and to do that we're going to need what I will call grid size. Since we're going to make it a rectangle, let's say that it's going to be a 20 by 20 grid, and then we'll do grid width and grid height. And I intentionally picked some sizes that are going to divide evenly here. So grid width is going to be width divided by grid size. And then height obviously is going to be height also divided by grid size. And there are ways you could change this up so you could have like grid rows and grid columns if you didn't want to be a square. But for our purposes, square is going to be fine for everything. So we'll say now, draw the grid for Y in range 0 up to, and then make sure it's an integer just on the off chance, because when you do division, even if it's a whole number into a whole number, Python defaults by turning that value into a float. So you did math, and now instead of it just being 480 divided by 20, which is like 24, it's going to be 24.0. And we want it to be an integer so that we can iterate through the loop. So that's why use the int in that place. And then do integer of grid height, and then underneath that do for x in range, and then that'll be from 0 to, in this time, an integer of grid width. Okay, and then a couple parentheses, close it out. And then what we want to do is actually make it a checkerboard pattern. So you don't have to do this step. You could just draw every rectangle the same color, but checkerboard is going to look a lot better, as you'll see once we get this drawn. So what we'll say is if x plus y, and now I'm going to use something you maybe don't see all the time if you're not super familiar with Python and object-oriented programming. It looks like the percentage sign. It's actually the modulo operator, I think is what it's called, but it's basically division checking for remainder. So what we're saying is if x plus y divided by 2 is an even division. So there's only two things that could be here, right? It could be an even or it could be an odd. So it could be 0, 2, 4, 6, 8, or it could be 1, 3, 5, and 7. And the evens are when this remainder is going to be equal to 0. And we'll draw our rectangle, which we'll call rect. We're going to draw that to be a slightly different color when it's an even number than when it's an odd number, and that's how we'll get our grid. Okay, so we're going to define the rectangle, and I'm going to do this again procedurally generated so that it works for every rectangle in the grid. Not really procedurally generated, but generically enough that it'll work for every rectangle in the grid. So we'll take our x and y integer, which again are telling us what position in the grid they are, and now we're defining an x and y start coordinate as well as width and a height. So we've got, we want the x and y start coordinate, and the way PyGame draws objects is 0, 0 would be at the top left corner, and then as you go to the right and down the screen, you go farther out. So 480, 480 is the bottom right, 0, 0 is the top left. So we'll do x times grid size and then y times grid size, and that'll mean that whatever integer you are in your rows and columns, that's where your top left corner is going to be. And then we need to give it a width and a height, and what's easy about that is they are both the same. Since we made everything square, it's just going to be grid size by grid size. And then, so there's two steps to getting a rectangle actually on the screen. There's defining the rectangle, but then there's also pygame.drawRect, and this is where you could technically combine steps. You could do pygame.draw.rect, and then you could also define the rectangle in there, but it's a little bit messier than just doing it this way. And so we need to give it a color, and I'm going to do colors in the same way that I do the rest of these game variables, where rather than typing in RGB values for everything, I'm going to define a color down here. So if I want to modify colors later in the game, I can just come right to one spot, and I think that's going to be way easier. So for grays, if you're not sure, and to do our checkerboard, we'll do 2 shades of gray. For grays, if you just basically make your R, G, and B values all the same, you're going to get various shades of gray. So that's what we'll do here. And then we're going to take almost that exact same code that we used to draw that one, and we will say else. We don't even have to check math here. And then we'll say rect is the same thing, so it's the same rectangle, but this time we're going to make it rect2. Okay, so we have our grid drawn. We have the overall like boxes that the snake and the food are going to move around inside of. So let's start actually defining the snake and the food. But to start, let's think about the snake, and let's think about all the different things that the snake is able to do. So with basically every class, any class of any kind of complicated functionality, you're going to want this def init function. And then you're going to put a few things inside of this. So you'll start, you'll put like how long the snake is. And then since the body gets longer as you eat more food, you're going to want a list of all the positions that the snake occupies. So you use this self.positions equals, and then make a list. And then initially, so what we're doing right here is we're initializing the class. So initially, we're also going to put its position just starting in the middle of the screen. And then obviously as you move through the game and you eat more food, that changes and updates, but we're going to handle that in other functions. And then the self.direction is going to be either up, down, left, or right. And so we will go ahead and make the handling for how you actually make all those movements in a second. But to start, let's say when the game boots up, you're going to move in one direction. Let's just use the random module that we imported in the beginning to choose which one you want to do. And we haven't defined these yet, so let's go ahead and let's go down into our game variables and actually define what up, down, left, and right are going to mean in the context of this game. So I'm going to go ahead and make a variable for all 4 of these. And it's kind of neat if you think about if you think about a grid and what we just talked about with how PyGame draws objects onto the grid. Up, down, left, and right can each be expressed in terms of a tuple or a set of 2 coordinates. So for up, your x isn't changing and your y is going up on the screen, which is actually negative because 0, 0 is at the very top, 480 is at the very bottom. So if you're going up, you have 0, negative 1. If you're going down, you have 0, positive 1. If you're going left, then you have a change in the x direction, but not in the y direction. So -1, 0. And then if you're going right, it's the opposite. You're going 1 and then no change in the y. And the reason we're doing it this way is we're thinking about the map as a grid system. And so this is telling how our coordinates on the grid need to change based on what direction we're going. So this is a really cool, intuitive way of setting up the movement. And that's why when the snake boots up right in the beginning, we'll have it randomly go in one direction or another. It won't really matter because you can't collide with one instance, so you're not going to be at risk of hitting yourself right when the game starts. Okay, and then let's go ahead and use self.color. So later in the class definition, when we draw the snake onto the screen, we'll have already given it a color. Let's come down into our library by the other colors and let's give it a nice green that's not like too complicated. Let's just do RGB. Let's just do all the way green. That's a little vibrant. You may want to change this up, pick your own colors. That's totally up to you. I just like green. It's very typical. So then let's use a little function to get the head position, get head positions, because we're going to need to check where the head is to be able to check. Oops, I always type self in twice. You're going to need to check where the head is to check if the head is colliding with the food. So this way, all we'll do is we'll check where on the grid the head is, and then we'll check the position of the food. And if those two are the same, then we'll know that it's time to grow the body of the snake by 1, regenerate a new piece of food, and it give you +1 for your score. So we're going to need this function, but all we need it to do is return where in that positions list the first item is. So self.positions 0. Okay, now let's talk about how to actually take a turn. So to do this, we'll define turn and we'll say self, and then we're going to need to pass in another variable which we'll call point. Okay, and so what we want to check is if self.length is greater than 1. So this is going to be as soon as you've eaten at least 1 point of food. And then we'll check if the first coordinate of point, because you got to think self, we're checking our x and y coordinate to be able to turn. So we're checking it against a point, which is going to also be an x and y coordinate. So what we'll do is we'll check point at 0 times -1, which means that you're turning, right? Because if you're going left, then what you're doing is you're moving in the x direction and you're not moving in the y direction. And if you want to turn to the right, then you're flipping that. You're going to multiply both the -1 and the 0 by -1. If you think back to how we define, let me say that another way. If you think back to how we defined the 4 turns, anytime a turn is taken, you're able to multiply both of these by -1, because if you're up going down and you multiply 0 by -1, then it's not going to change. And then you multiply -1 by -1 and it will change. So it's going to be this, and then comma, and then hopefully you see where it's going. 0.1 will be times -1. And what we do is we check to see if that is equal to self.direction. And if it is, then we can just return, because we don't have to do anything. We're already going in that direction. But else, we'll set self.direction equal to the point that we passed in. So that's how we'll check for turning. And some of this stuff that I'm going through is going to make a lot more sense once we actually boot up the game and you can see it in action. So for now, just bear with me. If you have any questions that aren't answered as we go through the tutorial, feel free to ask them in the comments below, and I will get back to you as soon as I can. Okay, so next, let's actually handle moving the snake. So we'll say define move. I always type self in twice when I'm doing tutorials. And we'll say current is going to be equal to self.get head position. So that's going to tell us where the head is. And then we'll create a variable x and y, just coordinates. And we'll set equal to self.direction. So that's what's going to be up, down, left, or right, depending on the player's interaction with the arrow keys. And so x and y will become variables that we can use in place of the 0, 1, -1 of our movement directions. And now what we'll say is our new location is going to be equal to, and we're going to need a few sets of parentheses. And so the new location is going to be equal to the first character of current plus, and then this is going to be equal to x times the grid size. And then we're going to use, again, so close that off, and then we're going to use, again, the remainder function, the modulo, divided by the overall width of the game. And then that's going to be the first coordinate. And then the second coordinate, open new parentheses, is going to be equal to current at the 1. So this is the second item inside of the coordinates. And then it's going to be equal to that plus, and then open the parentheses, y times the grid size. And then, again, we're going to use the remainder operator. Okay, and this, hopefully, now that it's typed out, you can stand back and look at what each piece of this is actually doing. But what it's basically saying is okay, whatever direction you're going, it's either moving 1 square up, 1 square down, which is why we can use these direction coordinates, the x and the y, because if it's positive, then what this is doing is adding 1 square to the right, 1 square to the down direction. If it's negative, it's going to add 1 square to the left or 1 square to the up. And due to the 4 directions, it'll never be doing both, right? One x or y is always going to be equal to 0, and the other one is going to always be equal to either 1 or -1. So the only 4 things you can do in Snake is move 1 square to the right, 1 square to the left, 1 square up, and 1 square down. And then all we have to do is move the rest of the body into the next spot that the piece in front of it took. So that's what we'll do next. I just hope that explanation was semi-clear. I know it's coding is always a little bit easier to write than it is to explain, I find, but okay. So what we'll do next is we'll check if the length of the positions table of the list is greater than 2, and our new position is already in the self.positions library after the second place. So this is checking from the second body part in the positions library all the way through to the end. And if our new position is already in there, then we're going to need to reset. So we'll make another function for that next. But basically that means that we've just collided. Wherever we just commanded our body to go, it hit a piece that already existed. So that means we need to reset, and that we basically lost the game, or our snake body has to reset. But we'll say else self.positions.insert, and then in place 0, we'll put the new coordinates. And then if the length, again, of self.positions is greater than self.length, then what we're going to do is, oh, I put one too many parentheses in there. Then what we'll do is we'll pop the last position off. So self.positions.pop. And pop is just a list function that always removes the last function from it. And the reason we're doing it this way is because when we do hit ourselves and we reset, we're going to reset our length back to 1. And this will just allow us to remove all the positions that are on the body too long now back, so we get just the head. So that'll probably make a little more sense now that we do this next one. We'll just define the reset function. And we're going to, so this is anytime the snake hits itself, which resets the game. We're going to set the length back equal to 1. And then I'm going to grab the self.positions and self.direction that we put up here and just copy it down, because this is what we're doing. We're reinitializing the game so that you're back to a length of 1. Your head is back to 1. Technically, you could reset the score to 0 here again if you wanted. I think it's okay if the score is just rolling and goes up, up, up until you have completed the game, until you're done playing. So technically you get a high score just as long as you want to grind, but your snake body will limit. But you could totally put score in this reset as well. Okay, but now let's go on to a really important one, which is going to be drawing. And for this one, we're also going to want to pass in what surface we're drawing the snake onto. And what we'll do is we'll say for pause, which I'm going to just use as an abbreviation for positions, and we'll say for pause in self.positions, we'll say that this time, kind of like before when we drew the grid, rect equals PyGame dot capital R rect, and make sure you get the cases right on these, because PyGame has some built-in stuff where you actually have to use case-sensitive capital R's. So we're defining a rectangle now, which is going to say where and what size we want the snake body segments to look like. And so we're doing this for every position in the positions table. And we're going to say the x coordinate and the y coordinate are where we want it to draw on, which is why we defined the grid in that way. And then the size, again, we already have a variable for the x and the y coordinate of the sorry, not the x and y coordinate, the length and the width for the snake's body. Okay, and so then what we'll do is we'll say pygame.draw.rect, and we'll put it on the surface. And you could totally just do green right here, but we actually did something I think is a little bit better, and we defined self.color a little earlier on. And now we can just do rect. And I think what you'll see, you don't need this step if you don't want to, but I'm going to draw the exact same rectangle on the screen, except this time we're going to make it an outline. So we'll make it black, which will, I don't think we've defined that yet, so we'll have to make another one. But what I'm going to do is I'm going to add this other condition, which is a width. So this is how you make a hollow rectangle. You define a width for it, and so we're just going to make it width of 1, which will make it a real skinny line. You could do width of 2 or 3. You can play around with that one if you want. But we'll say black is equal to 0, 0, 0, so that we can continue using colors instead of directly defining the RGB variable values. Okay, so surface, black, rectangle, and that is everything we need for drawing. All right, and now I really did save the most important two functions for the end of this class here, but the next one is handling keys. So this is basically our event handling, and what we're going to do is for event in pygame.event.get, and this is PyGame's built-in handler for tracking everything the player does. Every keystroke, every movement of the mouse, everything the system's doing is in pygame.event.get. Okay, and so the first thing we need to do is, what do we do if you want to quit the game? So if the event.type equals pygame. And then all caps quit, and then all you have to do underneath that is pygame. And then this time not caps, quit with parentheses, and then use that sys.exit as well to actually close the program. Okay, and then that's the boring one that you have to put in every game, because when you boot up Python, if you don't put that in, the little red X in the corner isn't going to do anything, and you'll have an infinite while loop that never ends, and then your game will crash immediately. So the more exciting code for this game is if event.type is equal to, and then you want to check for this game, everything we're doing is with PyGame.keyDown, but there's also key up, mouse button down, mouse scroll wheel, things like that. So just keep that in mind. But all we have to do here is check if the event.key is equal to, and we'll start with up, so k underscore up, and then if that's it, then we'll take a turn where we go up. Okay, so the nice thing is the way we defined the class is we don't have to do any complicated code in this event handling. We can just call the correct subfunction with the correct point. All right, so then we'll say else if it is down, then we will take a turn down. And you don't have to make these elifs technically. If they were just ifs, it would work. But that can get weird if you press multiple keys. The nice thing about elifs is if you're pressing multiple keys, it'll just look at whichever one completes the if statement first, and you don't have like overlapping code. But really, it's a cleaner, more efficient way to write the code, because never in Snake are you able to turn two directions at once. You have to do them as separate keystrokes, no matter how close in time they are. Okay, so that's really the entire event handling for the Snake. And we'll see where we call all of these sub-functions down below once we define the food class. And fortunately, the real meat of this project was in the Snake class. The food class is a lot like what we just did, but way simpler. So just like before, because it is a class, you want this init self right at the top. And then for self.position, let's just put the first one at 0, 0. And then self.color, we'll set this equal to red. Food, red is kind of classic for, credits. Red is kind of a classic Python, Snake color. I almost said Python because that's what we're doing. So we'll say R of 255 and then G and B of 0. Feel free to play around with the colors. You don't have to follow this. And actually right in the beginning when this thing's initialized, we'll want to randomize the position. So that position 0, 0, we obviously don't want that to be the actual starting position, but we need to initialize the variable self.position, which is why we did it there. So first things first, let's make a function called randomize position. And what we'll do is we'll set self.position equal to, and we're going to use the random module we imported, random, and we'll do .random integer, and we'll have it go anywhere from 0, which is all the way at the left of the screen, through to grid width -1, because we don't want it to be off the screen. And then we'll multiply it times grid size. So that will make it actually its x starting coordinate. And then we're going to do the exact same thing. So I'm just going to copy it, random.randint. Technically, you don't even have to change it to grid height because it's a square, but it's proper, especially if you're going to play around with the sizing later. Make this grid height -1. And then right at the beginning, when you call self.color and self.position, also just call this function once so that it runs right in the beginning and places the first piece of food somewhere random. Okay, so then let's create the draw. And this is going to be a lot like the player draw because it's or the snake draw, because it is also just going to be a rectangle, but this time we only have to draw one because the food is ever only occupying one grid location. So I'm just going to copy those 3 lines from the snake draw function, but we're going to modify it to be accurate for the snake or the food. So what we want is self.position at 0 and self.position at 1 rather than that intermediate pause variable, the indexer variable. And then we still want to be grid size, and we'll still use self.color, and we'll still use an outline. So you can see right away how the way we set up the class for the snake works really well for the class for the food. Okay? So this is actually everything we have to do to define both classes. Now let's just go down in the main loop and make sure that we call the correct things inside of the main game. Okay, so we already have the clock ticking. Let's go ahead and drop PyGame.init in this loop, actually. You could put it right up here at the top. That's totally fine. But let's put it inside of our main loop so that once it's called, we initialize everything. And let's see once we run it if that throws any flags. I like it there a little bit more. Okay, so after the surface, we draw the grid, and then let's go ahead and create our classes just like before. Score equals 0, wall true, clock equals tick. All right, and so the first thing we want to do is snake.handleKeys. So every time through this, we want to check if the players interacted with the game and do that first. Then we'll draw, and then we'll actually move the snake's body based on whatever current direction it's going. And here's where we should check if it has eaten the food. So that's if snake.getHeadPosition is equal to food position. And if that's true, then we want the snake.length to be 1 longer than it just was. We want our score to be 1 greater than it just was. And we want to run the randomized position function for our food again. So it's going to give us a new randomly located food position. And then we want to draw the snake again because now it could be longer if it actually ate the food. And then we want to draw the food again wherever it got located to. And then let's see, we want to screen.blit. So if you're going to do what I talked about right at the beginning and you're going to create a surface separate from the screen, you need to make sure that you actually draw your surface onto the screen. Otherwise, this game is never going to get displayed anywhere. So to do that, you do screen.blit, and then what you want to blit or block transfer, you're just saying what data you want to push onto the screen. And in this case, we want it to be everything that's on our surface, and the coordinate we want it to be on is 0, 0. The only reason you would not put it at 0, 0 is if this was like a pop-up or a partial screen or a sub-screen inside a larger screen. So we'll put it at 0, 0, and then let's put text on the screen that's going to tell us what the current score is. So to do that, we'll do text equals font.render. And then we're going to do it this way. We'll say score of, and we'll say just 0 initially. But by putting it in that curly brackets, we can come here afterwards and do dot format and then tell it what variable to put in that formatted curly brackets. And we'll say score, true, and then black. And then what we have to do, you see we're getting the red underline in under font, is we actually have to come up and define a font. So underneath our up, down, left, right, let's say font equals pygame.font with a lowercase and then font with the caps. And we'll say, so I like to use free sans bold in my games just because it's built in to any computer running Windows, and make it size 30. So that's just a good font size. You can make it smaller if you find that's kind of disruptive to the game. And actually, since we're doing that outside of the game loop, we are going to want to put pygame.init here as well, because if you try to run it, you called a font here, you need to have initialized PyGame by then. So now you can see we're not getting the red underline anymore, which is good. And then just like we did with the surface, we also have to blit the text onto the screen. And I'll just put it 510, so it's a little bit to the right and a little bit down. And this should be everything we have to do. As you can see, like there's really not that much to put in the main game loop if you set up your classes so that they take care of most of the complicated functionality. And if you go back through this, so we'll run it in just a second, but if you go back through this and you look at each subsection of code, you'll see at no point is there a really complicated operation. It's a lot of really simple operations that when combined give you cool functionality. That is the essence, that is the benefit and the bread and butter of object-oriented programming. So, knock on wood, let's see how close we got and what kind of troubleshooting we have to do. Okay, so right away, it moved to the left without me pressing anything. And if you boot this up a few times, you should see it going in different directions to start. I hit the food, my body grows by 1, the score gets bigger. I can move in all 4 directions. If you find it's too slow or too fast for your liking, try changing the speed at which that PyGame.time ticks at. So for example, if you were to go from 10 up to 20, you would find the game extremely difficult. It would move so fast. But like 12 and 15 are just slightly more challenging, because what that clock.tick is doing is saying the number of times to run through the loop per second. So basically 10 is saying it'll only move 10 squares per second. If you bring that up to 20, it'll move 20 squares per second. And since our grid is 24 by 24, that's going to be clear across the entire board. Okay. And so here you can see it's really cool. It can move off the screen to one side. And I hit myself there because I got longer than the board. We kept the score going. So that was one thing I talked about. Different games of Snake are they operate in different ways. Some of them reset the score every time you die. Some of them, it's just as long as you want to play in one sitting, that's your score. But your Snake body resets every time. And honestly, no one's competitively playing Snake. They're playing it for fun. So make it your own. This is really a great exercise to learn the basics of Python and PyGame. I think it's a really great beginner tutorial. If you did find this enjoyable, be sure to check out the channel. We have a ton of game tutorials ranging from other basic ones like Pong all the way up to pretty complicated ones like entire apps like idle clicker apps. We did a Space Invaders tutorial and a lot of other things that range from super basic to intermediate. Don't really do too many advanced things because the advanced people typically know what they're doing. But I hope you enjoyed this video. If you do have any questions or ideas for what you'd like to see in the future, be sure to let me know about in the comments below. As always, I really appreciate the support, and if you'd be willing to leave a like on the video, subscribe to the channel, it helps me out a ton. And as always, good luck with your code, and thanks for watching. Thanks, bye.